Hi guys, welcome to Chibuzor Mathphysics. Today we are dealing with the linear combination of vectors. Linear combination of vectors. What actually is a linear combination? Or how can you know that a vector is in linear combination with another set of vector? By definition, we say that if one vector is equal to the sum of the scalar multiples of other vectors, then we say that that vector is in linear combination with each other. And that is exactly what we have been asked or required to express. Our question is saying that we express that these values as a linear combination of vector A and vector B. So we are going to introduce what we call an arbitrary element. It could be arbitrary element pi, you could use alpha, you could use theta, or any of those Greek letters that will help you in expressing that that value you were given is in linear combination with those vectors. It could be three vectors, like in our case, we are having vector A and vector B. So let us introduce alpha to be our vector so that it will represent these values 22, 57, and -6. So we let alpha to represent a vector such that we know that we are giving vector A to be 4, 9, and 3, and B was -2, -7, and 6. So this is our two vectors. Of course, you need to put this cap, A cap and B cap, because now we are referring to vectors. And you know, in vectors, it also shows the direction and the magnitude of what we are talking about. So you must put this cap, A cap and B cap. So we have introduced alpha. This is a Greek letter alpha, and this is what we are given, A and B. If we are given A and B, now we are to express that the alpha, which is our vector alpha, as a linear combination of vector A and B. So that's exactly what we are expected to do, to express that vector alpha is a linear combination. We express this vector as a linear combination of vectors A and vector B. And to do that, like I said in the beginning, you know, this is an abstract math, and having introduced an arbitrary element, which is alpha, we are going to introduce an element that will go along with these two vector A and B. So we use X and Y so that we will have our vector alpha to be equals to AX plus YB. Or you can make it to rhyme together by saying XA plus YB. XA plus YB. So our vector alpha will be, we know that X will be given by vector A, which is 4, 9, and 3, plus Y into -2, -7, and 6. So this will give us alpha is multiply this by the variable you have 4x, and you have 9x, then you have 3x. plus here you have negative 2y, negative 7y, and then we have 6y. So that is the first thing we have to do. And I haven't expressed our vectors in this form. This will help us now to represent. Remember, our alpha is represented by 22, 50, 57, and negative 6. And negative these values is equal to what we have here. So we need now to compare on both sides. When we compare on both sides, we end up with three systems of equations. And that systems of equation will help us to get the value of x and the value of y. And then we express them as a linear combination. Let us see from there. So from here now, we know that our alpha, which is the vector alpha, is given by 22, 57, and negative 6. And this is equals to 4x, 9x, 3x. We add to negative 2y, negative 7y, and then 6y. So if we add these two together, this will give us 22, 57, negative 6. This will be equals to 4x minus 2y, 9x minus 7y, and then 3x plus 6y. So we need to compare both equations, compare both sides, both this and that. This will give us 4x minus 2y is equals to 22. And the second one will be 9x minus 7y is equals to 57. The third one will be 3x plus 6y, and this is equals to negative 6. This will be our equation 1, this is our equation 2, and this is our equation 3. So now we can solve for the value of x and y in order to express those values as a linear combination of each other. At any point in time, you can just pause the video, you try to do it yourself, follow systematically. You know, mathematics is all about steps, so you need to be able to follow, but then you don't cram it. It has to be logically followed, and there is no need of trying to cram whatever I'm doing here. So you need to have the formulas in your head, know the values that you are expected to analyze, get your vectors ready, then express them as a linear combination of that vector A and that of vector B. So now we are having three systems of linear equation. We can decide to use any of the method to solve it, either elimination or substitution method. And I will think we might need to eliminate some things, but then for us to solve this as a system of equation, we need to make sure that one of these values are the same, so that we eliminate x or y in order to find the value of x and find the value of y, and afterwards express them as a linear combination. So solving equation 1 and 3. So let us take equation number 1 and equation number 3 and solve them simultaneously. This is our systems of equation. 4x minus 2y is equals to 22. Equation 1. We have 9x minus 7y is equals to 57. And this is our equation 2. We have 3x plus 6y, which is equals to negative 6, to be our equation 3. So that is what we have. So we take equation 1 and 3. Equation 1 and 3. What we are going to do in order to get the same value, if you see in equation 1 we have negative 2y and we have 6y. And our target is to make sure that these two y's are the same values. So we can multiply both sides by 3. So we can say that in equation 1 multiplied by 3. This means that 4, we have 4 here, so 4 multiplied by 3 will give you 12x minus 3 multiplied by this will be minus 6y, and then this will give you 3 by this. 3 multiplied by 22, that will give you 66. That will be 66. And then we have our 3x minus 6y is equals to negative 6. So now we have the same values in both y in equation 1 and equation 2. So that you end up by, you add these two, 12 plus 3, this will give you 15x. This is a addition sign. Minus 6 plus 6 is 0. Then we have 66 minus 6 will give you 60. So that our x will be 60 divided by 15. And this is the value that we got for x. So that now we can solve for the value of y. And afterward, we are able to use it to find the linear combination of each other. So now what we are going to do is to use equation 1. We try to substitute the value of x. Of course, you can go further. If you divide this 60 divided by 15, this will give us approximately, this will be 4. So now we are going to use equation 1, and equation 1 will help us to solve for x, for the value of x. And we know that equation 1 we have 2. Equation 1 we have 2x. Equation 1 was 2y is equals to 4x minus 22 from what we have in equation 1. And we are solving for y. Y is equals to 4x minus 22. So to solve for the value of y, we will have 2y is equals to 4. Our x is 4. So we just plug in 4 minus 22. This will be 2y is equals to 16 minus 22. So 2y will be equals to 16 minus 22 will give you negative 6. 16 minus 22. Yeah, 16 minus 22 is going to give us negative 6. So here we have -6. So y will be given by -6 divided by 2, which implies that the value of y will be -3. And this is our solution for both x and y. Remember, the value of x is equals to 4, and the value of y is equals to -3. So now we are almost done to the question. The last step is to substitute. So we substitute the values of x and y in A. Remember that we have our A, which was the two vectors we got. We have a vector A to be 4, 9, and 3, and vector B to be -2, -7, and 6. So we need to substitute this value of x and y in that our two vectors, so that we are making both values to be in linear combination with each other, and that will be our final solution. So let us see how to conclude. So we'll get the value for x is 4, but remember our alpha was 22, 57, -6. So this will be equal to 4 into this value of A, which is 4, 9, and 3. And for B, we have -3. B, the value for B will be given by -3, which is -2, -7, and then 6. And this is what we're expected to do to express that two values as a linear combination of each other. So this value minus this value is what we're expected to do, and we are good to go. So usually in linear algebra, you are given a question and you have to express that value as a linear combination of a certain vectors. It could be two vectors, it could be three vectors. So you are expected to solve, first of all, introduce an arbitrary element. It could be alpha, it could be maybe pi, it could be theta. Then use x, y, or z if you are given three vectors. But don't forget to always indicate that is a bar or x bar, because you know this is an arbitrary element and it is a vector, so it needs to show direction. So that's exactly what we expected to do in this video, and we are good to go. Don't forget to subscribe to this channel. I will see you in the next video as we go into proving what is a null space and how can you recognize that a vector space is span, because we are going to introduce a new term, what we call span, and even vector spaces that are in 4 dimensions. Do well to subscribe, and God bless you for watching.